Hey there, friends. Tyler Vanderhoeven here. I've got another passkey smart wallet policy signer demo that I want to show you. This one's demonstrating kind of what I'm calling stateful policies, or policies as protocols. If you haven't been following along, I've been working on a big update to my Stellar Smart Wallets account abstraction protocol proposal for what kind of a version 1 of smart wallets could look like on Stellar, thanks to Sorbonne, and particularly that composable auth, that check auth function that we have available to us, combining ED25519, or like classic G-address signers, and the SecP256R1 passkey WebAuthn signers, and now this new third type, policy signers, which are basically smart contracts that can authenticate. And the ability for those things to also now combine together into beautiful, wonderful services. So I've built this cool service called Zafegard. So we're going to sign up with a brand new passkey. It's worth mentioning, as this kicks off, it'll run some things in the background to basically set up our Zafegard wallet. But it's just a smart wallet. There's no like custom smart wallet stuff going on. Everything that's being set up is being set up on this custom policy that I've made that then will be used whenever we make a new signer, which you'll see in a minute. You'll add a new signer, which then has this custom stateful policy attached to those signers. So there we go. It's all set up. We have this new smart wallet, which if we look it up on Stellar Expert, on the testnet, we'll see it's got those 10 lumens in it. It's just got the one passkey signer attached to it, this SecP256R1. So nothing custom, nothing weird. You don't have to fiddle with the wallet. It's just this is the wallet standard that I'm proposing. And what's so amazing is that everybody will be using the same wallet, but we get loads and loads of cool custom functionality through policies. So where other services in Ethereum or Base or the ETH ecosystem, if you want cool custom functionality, you're going to need to use like a bespoke wallet, transfer funds over to it, and use their bespoke wallet. In my world, everybody uses the same wallet standard, and if you want bespoke custom logic, you'll just make a new policy and then attach it to the wallet, which is nice because now you don't have your assets split between a bunch of different bespoke wallets. Everybody uses the same wallet, and then you just interact with different protocols or services through that same wallet, which is really, really cool. Okay, so basically what Zafegard does is it's got this like root address that you then attach child or sub accounts to, and then those sub accounts have parameters under which they're allowed to spend the root balance. So let's go ahead and attach one of these, and we'll see what that looks like in just a minute. So this is basically making a new ED25519 signer that has this policy, the Zafegard policy attached to it, this stateful policy. And so essentially what this stateful policy, this is Zafegard policy, allows is for these ED25519 signers to spend the balance of the root smart wallet account, but under a certain set of parameters. In this case, it's allowed to spend 100 lumens every 10 ledgers. So if we go ahead and we spend that, we'll see this balance decrease by that 100 stroops. There it is. And if we try to spend again, we'll get an error because it's not time. You're not allowed to spend 100 more stroops because it hasn't been 10 ledgers yet. So you could go and basically take this secret key and go share it with, I don't know, a service, your child, your colleagues, your employees, and they're allowed to then spend off of your parent account without having direct access to your account. They are allowed to spend on it, but only under the conditions of the policy. So we could, if we wanted to, update that. I am going to keep it at 10 ledgers, which is roughly a minute. But let's go ahead and put this at a whole lumen, which is 10 million stroops. We'll update that. And because this is a something we don't want the child account, the sub account, to do. It's not allowed to. It's only allowed to call transfer functions. And so the root account, this passkey, will have to sign for this, which will basically sign a function on the policy itself. So instead of the policy just having that one policy underscore underscore, the policy has a bunch of other functions because it's just a smart contract and it's stateful. So there's some state that's stored for these different addresses that you can then update the parameters under which this particular address can operate. If we go back over here and we refresh, we'll see that it now has this 1 lumen able to spend every 10 ledgers. It's probably been about a minute by now. So if we spend, we should see this decrease down to 18,999. You might be wondering why it's, oh, well, yeah, there it is, 17,999. But why it increased from 10 to 20. I've got a little function in the background that basically says, if the balance decreases below a certain amount, just go ahead and increase it. Give me a little more friend-bot money so that we can add a bunch of these child addresses and start spending them. So that's nice. We just spent that money. I don't think it's been a minute yet, so now we're back to too soon again. So that's super cool. It's almost like a subscription, kind of a manual subscription, if you will. There's like a couple of interesting features. I don't really care that much about the details of Zafegard, but it's customizable. It's composable. You could have it be whatever you want. In my particular case, if you miss an interval, it will stack intervals. So you'll be able to spend, like, if you wait 20 ledgers, you'll be able to spend 20,000 stroops. But you're also only able to call one time. So like whenever you do actually make a spend, it will reset. So it doesn't actually keep track of how much you spent. It just says, here's the max you can spend, but you can only make one spend call every 10 ledgers. And then again, if you wait like 100 ledgers, it'll be I guess 10 times 10 million. It's getting close to a minute. There we go. Maybe that'll decrease to 16 this time. Nice. We've got 2 of these now over here. Refresh that so we get our balance correct again. Because it's using LaunchTube on the back end, you don't have to worry about like sequence numbers. I hold like a pool in LaunchTube of accounts, so you can spend to these things. Oh, I guess I'm too soon on that one. Let me make another one. Look at that. It's working just like you would expect. But for example, just because I think it's so awesome, you can spend these things quickly without having to worry about sequence numbers. So all of these different accounts can be making transactions simultaneously in sequence. One of the beauties of LaunchTube. These should all now be too soon. This one might be past a minute. No, not yet. But we can update those if we want, but we'd have to obviously use our root account. We can share those to all of our different employees or children. We can delete these once we're done with them. Those can either just expire, maybe if they were temporary signers, or you can manually go in and close them out when we're done with them. Really basic functionality. If we look at the code here, the actual, like, this took me probably like 5 hours to build, and most of that was just the DApp code. Writing websites is hard, people. That's close to 600 lines of code just for the website. But the actual contract for this cool functionality is less than, I mean, it's 150 lines of code. Very simple. There's that policy. Not much going on here. You can see we're passing in signer now as an argument inside of policy. That allows us to grab a hold of that child ed25519 sub address, which we're actually storing. Here's the additional functionality, right? So the stateful policy now has some additional functions. We set up an initialize function, which basically says who's the admin, which would be the wallet. And the wallet will then need to sign for things when we're adding new wallets, when we're removing wallets, when we're updating wallets, and those are all those sub wallets. But those things are stored as entries on this policy, which then in this case is this user, and that's that bytes N32, which is the public key, that ed25519 public key, and that's what gets forwarded when that signer is used. So inside of the smart wallet when the policy is called, because somebody's using that ed25519 on our smart wallet. We basically call this policy because we attached that policy to that ed25519 signer. It says, hey, we need to like double check that everything looks good. And so it calls this policy on that signer and looks up like, well, when was the last time it was called? How much is it being called for? How much is allowed to call? And then we'll error on different parameters. And then if everything looks good, it returns, the policy passes, and all of that money can be spent, which is so cool. Pretty simple. And again, shows the power of policy signers on this smart wallet standard. Hope you enjoy it. Feel free to go to zafegard.pages.dev to try it out for yourself. Let me know what you think. Maybe write your own policy. It's a good time. It's awesome.